Ordinary annuities. Our objective, we want to define an ordinary annuity and find the future value and the present value of an ordinary annuity. Well, before we can talk about an ordinary annuity, what's an annuity? An annuity is simply a financial plan characterized by regular payments. So we're talking about fixed payments made on a regular basis over a period of time. So I'm paying somebody $100 every month, for example, or I'm being given $100 every month, for example, over a period of time. So fixed payments made over a period of time, regular payments of the same amount. Now they know what an annuity is. What is an ordinary annuity? It's a financial plan where equal payments are contributed at the end of each period, for example, monthly, probably the most popular, to an account that pays a fixed rate of interest compounded at the same time as the payments are made, for example, monthly. Notice the contributions, the equal payments at the end of each month, at the end of each period, the period has to equal the period down here, the compounding at the same time. So months equals months, or years equals years, or quarters equals quarters, etc. That is an ordinary annuity. All right, how do we find the future value? So if I do this, if I contribute equal payments at the end of each period into an account that pays an interest rate, and I do this, how much will I have in the future? All right, so the future value of an ordinary annuity, if our dollars are contributed at the end of each period for n periods into an annuity that pays an interest rate I at the end of each period, this period must equal this period, the amount you'll have in the future is determined by this formula. S, the future value, equals how much you're going to contribute each period. What is your fixed payment each period? All that times this division problem, 1 plus the interest rate per period raised to the number of periods minus 1 divided by that interest rate, which is at the end of the interest rate per period. Okay? So fair amount of jargon there, a lot of lingo. Let's do an example that I hope will help it make sense. You just need to be careful with coming up with I and N and then putting it into the formula. So I is going to require a touch of calculation and N is going to require a touch of calculation, and then we're going to make use of the formula and be all set. So example 1, how much will we have in 5 years? Given we have an ordinary annuity, we're going to contribute $500 per quarter. Okay, so quarter means 4 times per year. That's a quarterly rate every 3 months. And this account pays 8% per year. And of course, it's compounding quarterly because this has to match that in order for this formula to be valid. Well, here's my formula. The amount I'm going to have is equal to the amount I'm going to contribute every payment times 1 plus the interest rate per period raised to the number of periods minus 1. All of that divided by the interest rate per period. Well, let's first find I. Okay, I, it's 8% per year. So it's 8%, and this is per year. And we're going to divide that. Well, we're going to do this we're going to contribute and we're going to pay. We're going to compound quarterly. So we're going to do 4 times per year here, which means we're doing 0.08 divided by 4, which is a 0.02. Remember, 8% is 0.08, which is 0.02 per quarter. So 8% per year is 2% per quarter. 2, 4, 6, 8 to get to 8%. And that's our I, interest rate per period. So 2% as a decimal point 0.02, the period is quarterly. 8% per year is 2% per quarter. And what is N? N is the number of periods. Okay, how many periods are we talking about? Well, we're going to do 5 years. And we're doing, there are 4 periods because we're compounding quarterly. There are 4 periods per year. Excuse me while I erase what I just had there. So we're talking about 20 periods. Okay, 20 times we're gonna contribute $500 into this annuity. Okay, 500 per quarter is 4 times in 1 year times 5 is 20 periods we're talking about. So now we can apply our formula. S is equal to the amount we're going to contribute per period, R, 500, times 1 plus the interest rate per period, which is per quarter, which is 0.02. Oops, I forgot my parenthesis here and here. Minus 1 divided by, raised to the N. Forgot a couple things. Sorry, folks. Raised to the number of periods, which is 20. And now we'll subtract 1 divided by I, the interest rate per period, which is 2%, 0.02. And all of that can go into a calculator. And out comes $12,148.68. Whoops. Let's put that so you can see it. How about that for an idea? All right, so if I contribute $500 every 3 months into an account that pays 8% per year, which is 2% per every 3 months per quarter, in 5 years, I will have $12,148.68. That is the future value. Okay, so let's make a note. The amount, this number is the amount the annuity will be worth in 5 years. There you go. That's how you make use of the future value. Oops, come down a little bit. That's how we work with the future value of an ordinary annuity with that formula right there. Now let's talk about the present value. We're back to I want so much money to be coming to me. How much must I put away to have that happen? Okay, so the present value of an ordinary annuity. We're looking to have a payment come to us, for example. Okay, we want our dollars to be made at the end of each period for N periods from an account that earns an interest rate of I per period. How much do I need to have in the annuity today to have that coming out on a regular basis? This is a bit like a retirement type plan. Okay, and that's what our example 2 here speaks to, is how much do I need to sock away now so that I receive regular payments for X number of years. Okay, how much do I need? I need to put a lot away if I want to have money coming into me on a regular basis for a number of years. So here's the example. Suppose a retiring couple wants to establish an annuity that will provide them $2,000 at the end of each month for 20 years. That's a fair amount of money. $2,000 per month times 12 months is $24,000, and they want that to take place for 20 years. Okay, now we're getting into the we're getting into the hundreds of thousands of dollars. We're going to need some money here to do this. present value. How much do I need to have, how much do I need to put into this annuity today so that this will happen? The annuity earns 6% compounded monthly. Of course, they want money at the end of each month, so we're going to compound it monthly. How much must the couple put into the account to establish that annuity today? Okay, here's my formula. A is equal to R times, it's this one, so it's 1 minus 1 plus the interest rate per period. Notice the negative in the exponent to the negative n, all divided by the interest rate per period. Again, n is number of periods, and that's the formula. We need to calculate the I, because it's not an annual. It's not this is 6%. But we got 6% annual. We need to make it compound monthly. We got to calculate the number of compounding periods we're talking about and how many months we're talking about. So we're talking about 6% every year. Let's divide that by 12. We want 12 times per year. And that 6% as a decimal is 0.06 divided by 12. And that comes out to be 0.005 per month, which is 0.5% per month. M-O-N-T-H. 0.5 times 12 gives me 6. Okay, and 0.5% as a decimal is 0.005. So there's our I. How about our N? How many payments do they want? Well, they want 20 years worth of payments, and they want payments at 12 per year. So they want 20 times 12, they want 240 payments, which is 240, 240 months is they want 240 months of payments, 240 periods, 240 payments. Okay, they want this to happen 240 times. Every month, which is 12, for 20 years is 12 times 20, which is 200. They want 240 payments of $2,000 when all is said and done. Okay, how much do they need to sock away today? Well, A is equal to this number, which is 2,000. And 1 minus, parenthesis, 1 plus the interest rate per month, which is 0.005. Raised to the negative, don't forget that negative, that's what students will miss right there. Number of periods, which is 240, all divided by the interest rate per period, which is 0.005, and we will, there we go, there's our formula. We will pop that into a calculator, and they need to put away today $279,162, and I rounded up to nearest dollar. They need to put this much away today. They have this amount present value. They put that amount into this situation, into an annuity that earns 6% compounded monthly, and that will give them $2,000 at the end of every month over a 20-year period. So this amount is the amount, hope you can see that. Let's raise it up a little bit here. The amount to put into the annuity today. Okay, that's the amount to put in the annuity the amount to put into the annuity today to have this situation take place. So there you have it. A couple of examples of how to work with an annuity.